Okay, so somebody in the second hour class made the suggestion that I should uh, make up a list of the different types of sequences that you might see and kind of how to decide which ones they are and how to decide what order to kind of look at these things in. And so what I've got here on the screen right now is the different types of rules that you might see for a sequence. And so they kind of, this is in order from what I would say is kind of the easiest rule to figure out to the hardest rule to figure out. And so easiest is starting with something like addition and working our way all the way up to those triangular numbers that are pretty tricky to figure out. So that is kind of how we'll do this. So let's go ahead and just take a look at what each of these types look like. So first one we've got here is an example of an adding rule. So an adding rule is one where you can look at these terms and just kind of, let's see if I can get this pen to work, and you know that you're just adding the exact same thing each time. So you're going plus 4, plus 4, plus 4, plus 4, all the way up. And so when we get to the nth rule, it's going to be pretty easy just to say, okay, that's n plus 4. And for any number, we just have 4 more than the term number. Those ones are going to be pretty easy to recognize. Remember, we are going from the term number to the term, not term to term to term when we're writing this nth term rule. The next kind you're going to see might be a multiplication rule. And these are going to be, again, fairly easy to kind of figure out when you look at them. So you'll notice right away that this is definitely not adding the same amount. 1 plus 2 is 3, but 2 plus 4 would be 6. So it's definitely not adding, but it is multiplying. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So it's always just times 3. And so when you get to your nth rule, you just write 3n. So that would be a multiplying rule. Where they start to get harder is when you start to get things that are like linear, rectangular, or triangular numbers, and you've got to figure out what they are. So this is an example of linear numbers. One thing you will notice here is it's not adding the same thing. That'd be plus 1. Trying to get my pen to work again. So that would be plus 1, that would be plus 3, that would be plus 5. It's not the same thing you're adding each time. It's also not the same thing you're multiplying by. This one would be times 2. This one's not even times a whole number. And so it's not multiplying or adding. The thing I'm looking at next is if I just look at these term to term to terms, I'm noticing that this is plus 3, plus 3, plus 3. That means that this is a linear expression. The first differences, like you learned about in algebra last year, are constant, which tells me that I'm going to end up, when I write my rule, with a 3n in there. If I'm adding the same number over and over again, that is the same as multiplying by that number. Now, if you look here, 3n is definitely not the rule. If I plug in 5 times 3, 5 times 3, that's 15. So that's not my rule either, but it is close. If you see 4 times 3 is 12, that's off by 1. 3 times 3 is 9. I always end up 1 higher than I want to be. And so the way I correct that is I'm just going to do minus 1. And so my rule here, 3n minus 1. Figure out what you're multiplying by, and then just adjust it based on how far off you might be. Okay, now here's where we get into the harder ones. These are your types of different quadratic. They're going to have an n times an n somewhere in there. And so the way you're going to tell that it's definitely more complicated than a linear is when you see these being changing. So this one is plus 3, this one is plus 5, this one is plus 7. And so right away it's telling you that's not linear, that is going to be quadratic. You see there it's going up by 2 each time. So that's telling you this is definitely a quadratic. And it's going to be a something time, n times n, or n minus 1 times n plus 1, something like that. So here's the strategy I would use if I'm seeing these. I start looking at the factors. So 0 is a hard one to do because it could be 0 times anything. So I'm going to start with 3. My only option for 3 is that it has to be 1 times 3. Then I go to 8. Well, 8 could be 1 times 8, but it could also be 2 times 4. Those are my options for 8. 15, well, it could be 1 times 15, but it could be 3 times 5. And then 24, I get a whole bunch of options. It could be 1 times 24. It could be 2 times 12. It could be 3 times 8. It could be 4 times 6. So I'll stop there. Looking through those numbers, picking one from each, is there a pattern? Do I see something that shows up in each that kind of has a pattern? Well, I know I'm going to have the 1 times 3. And looking through here, I see 2 times 4, 3 times 5, and 4 times 6. Each time the numbers in that are going up by 1, that's a pretty good pattern that I can follow. Now I can go ahead and turn those back and look at how do they relate to the term number. So I'll start with the first one. How do I get from 2 to 1? How do I get from 3 to 2? How do I get from 4 to 3? How do I get from 5 to 4? Well, that's always just one less. So I know I have a factor of n minus 1. Then I can go back and look at the other number. So how do I get from 2 to 3? How do I get from 3 to 4? How do I get from 4 to 5? How do I get from 5 to 6? Well, that's always one bigger. So I've got a factor of n plus 1. So let's try that out with 6. If I take 6, 6 minus 1 is 5. Times 6 plus 1 is 7. That equals 35. Yep, that checks out. That's my rule. So that's a rectangular number. You're looking for something times something, a length times a width. Rather than trying to draw these out as actual rectangles on your paper, listing out the factors, basically the possibilities of lengths and widths to make them into rectangles. Finally, the hardest example of all are the ones that end up being those triangular numbers with the length times width divided by 2. So these are the ones where you're going to see stuff like n times n minus 1 over 2. That's not what this one is, but you'll see stuff like that. Now, the way you can tell this is I'm looking through these and I'm saying, okay, well, that's plus 2, that's plus 4, that's plus 6, that's plus 8. The numbers I'm adding are going up by 2 each time. This is definitely a quadratic function. I know it's going to have that n times n in there somewhere. And then I can look at the factors. I don't like looking at these that are zeros and negatives, so I'm actually going to skip over those for now and just start with the 6. So 6 could be 1 times 6. It could be 2 times 3. 14, I could have 1 times 14, or I could have 2 times 7. 24, well, that could be a lot of things. 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And one thing I'm noticing here, it looks like I actually do have a pattern in that. Maybe I wrote one of these that's actually not triangular, and we'll have to go back and figure it out again. So just a second here. Yep, I wrote one that isn't triangular. So let me go ahead and back. This one's definitely rectangular because I forgot the divided by 2. So what this one is supposed to be, go back and fix this real quick. This is supposed to be negative 3, negative 2, 0, 3, 7, and 12. So let's try that one. This one's triangular. Okay, so again, I'm still seeing this. There's plus 1, there's plus 2, there's plus 3, there's plus 4. So it's definitely quadratic, but I'm looking through this when I'm looking for factors, thinking, it might be rectangular. I'm seeing, okay, 3 times 1, or 1 times 3, 1 times 7 is the only option there. That doesn't help. And I get to the 12s, it could be 1 times 12, 2 times 6, or 3 times 4. Well, the problem is between those two numbers, the pattern says take 1 times 3, 1 times 7, 1 times 12. That's completely not helpful. So that's telling me this is probably triangular. It's the last option I would really give you in this class. And so the deal with these is if these numbers are triangular, the ones I want to really deal with are double those. I want to double all the numbers because if I take a triangle and I double it, I get a rectangle. Imagine you've seen that before. Someone takes a triangle, makes a copy, spins it around, and it makes a rectangle every single time. So I'm instead going to deal with these green numbers. And I know those are probably going to be rectangular. So I'm going to go ahead and find the factors of those. Again, I'm going to ignore those. I'm going to start here. So this could be 1 times 6 or 2 times 3. 14 could be 1 times 14 or 2 times 7. And then 24 has a lot of options. 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And I'm looking for, is there one that's a consistent pattern going between all of those? Well, what I'm seeing here, I've got 1 times 6, 2 times 7, 3 times 8. That's a pattern that I like. It's a consistent thing that I'm seeing happening on all of these. And even if I were to go back and do 0, I could write that as 0 times 5. And then I could write this one as negative 1 times 4. And it would actually work going backwards. So I think that's my pattern. And now I'm going to go ahead and do the same thing I did for rectangular. Is there a way to get from 4 to 1, 5 to 2, 6 to 3? Well, that seems to be minus 3. So I have an n minus 3 term in there. Then I'll go in and look, is there a nice way to get from 4 to 6, from 5 to 7, from 6 to 8? And yeah, those are always 2 bigger, so I'm going to have an n plus 2. Now that rule there is going to get me these green numbers, the ones that I already doubled. If I want to get back to the black numbers, now I just need to throw a divided by 2 in there because I know this is triangular. And then that's going to be my rule. Go ahead and check that. If I plug in 6, 6 minus 3 is 2, 6 plus 2 is 8, so 6 minus 3 is 3, and then 8, so 3 times 8 is 24, divided by 2 definitely gives me 12. That's looking like my rule. Now, when I actually go to try one of these, like this is question 11 in the homework, I'm going to go through that list. I'm going to ask myself, first of all, is it adding? If not, is it multiplying? If not, is it linear? Then I'm going to try to see if it's rectangular, and then I'll go to triangular if I have to. So, am I adding something? So that'd be minus 2. That'd be minus 2. Well, that's not minus n. That's actually plus 4, so it's not adding. Is it multiplying? That'd be times negative 1. That'd be times 0, not multiplying. Then I'm checking my differences. Plus 1, plus 3, plus 5. That's a quadratic because it's changing by the same amount each time. It's going, the number I'm adding is going up by 2, so I know it's quadratic. So my first thought is, can I write this as a rectangular rule, just without the divided by 2? So I'll go through and I'll list out my factors. I'm going to ignore these because I don't like those. 1 times 3. 8 could either be 1 times 8 or 2 times 4. I'm starting to see something I like here. I know 15 can be written as 3 times 5. And I know 24 can be written as 4 times 6. So I am seeing something there. When I look at this, I see, okay, I'm first of all, I'm seeing the n, the number term, show up in there directly. So I know that rule is going to have an n in it. Whether I write it at the beginning or the end doesn't matter. Then I'm looking at the other term, saying, okay, from 3 to 1, from 4 to 2, from 5 to 3, well, that's minus 2. So n times n minus 2, that looks like my rule. Yeah, it's not a bad idea to check it out. 6, if I take 6 times 4, that is 24. So that's definitely the rule for that one. Finally, this is number 12 in the homework. I'm going to go the same exact thing. Is it an adding rule? No. Is it a multiplying rule? Definitely not. If I look at my differences, I'm going plus 2, plus 3, plus 4, plus 5. Well, it's not a constant difference, but it is, I'm adding 1 to the number I'm increasing by every time. So it's definitely quadratic. Then I'm going to go through and I'm going to look at my terms. I'm going to ignore the 0 because I don't like that. I'm going to have 1 times 2. That's my only option. 1 times 5. That's my only option. Either 1 times 9 or 3 times 3. I'm not seeing patterns I like here. The only pattern I see is just 1 times a number, and that's completely unhelpful. So that tells me that the only thing left it could possibly be is that these are triangular numbers. So I'm going to go through and I'm going to double all of them. 0, 4, 10, 18, 28, and 40. And I'll look at these now. 4 could be 1 times 4, or 2 times 2. 10 could be 1 times 10, or 2 times 5. 18 could be a lot of things. 1 times 18, 3 times 6, 2 times 9. I think that's all my options here. But I'm starting to see a pattern. I'm starting to see 1 times 4, 2 times 5, 3 times 6. And I know, hey, 28, I could write that as 4 times 7. And 40 could be 5 times 8. So I've seen the pattern. We're good to go now. So now I'm back to this. From the term number, how do I get to that first thing? How do I get from 3 to 1? From 2 to 1, from 3 to 2, from 4 to 3. Hey, that's minus 1. That's not so bad. So I've got an n minus 1. Then I'm jumping up to the other one. How do I get from 2 to 4, from 3 to 5, from 4 to 6? Hey, that's plus 2. And again, that is how I found the red numbers. I was working on those red numbers, which are double the ones I actually want. So to get back to those red numbers, I just need to divide that final answer by 2. That's my rule. It's a triangular rule. So that's the process. Start off assuming it's the easiest thing. Try an adding rule. If that's not it, try a multiplying rule. If neither of those work, check those differences. If the differences are constant, like we saw here, then it's a linear rule. Whatever those differences are, you know that's going to be the number in front of the n. If they're not common differences, here I see a plus 3, plus 5, plus 7. That tells you it's either rectangular or triangular. It's something that's going to have an n times an n in it. Assume it's rectangular first. Try to find the factors and look for a pattern. If it's not that, your last resort is to double all of those numbers and see if there's a pattern in those numbers. Look for the factors of those doubled numbers, write the rule based on those, and know that you're going to have to throw a divided by 2 in there as well. That is absolutely the hardest thing I would give you on these examples. But that is one way you can look at these patterns completely by the numbers without having a picture to go off of and still be able to find the rule. It's going to take you some time to go through all those options, and you really do want to go through those options because if it's an easy one like an adding rule, you don't want to be trying to make a rectangular rule out of it. Okay, hopefully that was helpful, and I will see you later.